Look up tonight. Pick any star. Not the sun, not the moon, a star. What you're seeing isn't there right now. It's a message, sent so long ago that the thing that sent it might not exist anymore. Here's the strange part. You already know this, technically. You've heard, light takes time to travel. But most people have never sat with what that actually means. So let's sit with it. Light is fast. Faster than anything else we know of. 299,792 kilometers per second. Fast enough that in everyday life, it looks instant. Flip a switch. The room is lit. No delay you can feel. But fast is not the same as infinite. And once you're talking about distances big enough, even light starts to crawl. Start close to home, the sun. It's 150 million kilometers away. Even at 299,792 kilometers per second, that trip takes time. About 8 minutes and 20 seconds. So the sunlight hitting your skin right now left the sun's surface over 8 minutes ago. If the sun vanished this instant, impossible, but imagine it, you'd keep seeing it, keep feeling its light, keep basking under a star that no longer existed for another 8 minutes and 20 seconds. You wouldn't know. Nobody would know. Not for 8 minutes. That's your nearest star. The easy case. Now go further. The next nearest star to Earth, not counting the sun, is Proxima Centauri, 4.24 light years away. A light year isn't a unit of time. It's a unit of distance. How far light travels in 1 year. So the light from Proxima Centauri that reaches your eyes tonight left that star 4.24 years ago. Whatever you're seeing is a 4-year-old broadcast. Now stretch it further. Sirius, the brightest star in the night sky, 8.6 light years out. Polaris, the North Star, the one sailors steered by for 1,000 years, sits around 430 light years away. The light hitting your eyes when you find Polaris tonight left that star sometime in the 1590s. Shakespeare was alive when that light began its trip. It has been traveling, uninterrupted, through the vacuum of space for over 4 centuries, just to land on your retina for a fraction of a second. Here's where it gets uncomfortable. If light takes centuries to reach you, you are never looking at a star as it is. You're looking at a photograph, except the photograph is real light, still moving, still arriving, right now, in real time. It's just old. Every star in the sky is a time capsule. Some are recent history. Some are ancient history. Some are older than history itself. And there's no way to tell, just by looking, how old the message is. So here's the question. This video is actually asking, if the light takes hundreds of years to get here, is the star still there? Stars don't live forever. They burn through fuel. Eventually they run out. Small stars fade slowly over billions of years, cooling into dim embers. But big stars, really massive ones, die violently and fast on a stellar timescale. They collapse, then they detonate. A supernova, briefly outshining an entire galaxy. And once a star like that goes, it's gone. The light stops being made, but the light already made, the light already in transit, keeps going. For as long as it takes to cross the distance, which means somewhere, right now, there could be a star in the sky that already exploded. Not will explode, already did, years ago, maybe centuries ago. And you're still watching its old light arrive, like a letter mailed by someone who has since died, still making its way through the postal system. This isn't hypothetical. It happened. We watched it happen. February 1987. Astronomers spotted a new point of light in the Large Magellanic Cloud, a small satellite galaxy near our own. They named it Supernova 1987A. But here's the catch. That explosion didn't happen in 1987. The Large Magellanic Cloud is about 168,000 light-years away. The star had actually died 168,000 years earlier, while early humans were still spreading out of Africa, long before agriculture, long before cities, long before writing. The explosion itself was ancient history by the time anyone on Earth had invented the alphabet. We just didn't get the notification until 1987. Think about that gap, 168,000 years between the event and the news. Now think about how many stars are out there whose notification simply hasn't arrived yet. Some of them might already be gone. We wouldn't know. We can't know. Not until their light finishes the trip. So which stars visible tonight are most likely to already be gone? Honestly, probably none of the familiar ones. And it's worth being precise about why. Because this is where the popular version of this fact usually oversells itself. Most naked-eye stars are relatively close, a few dozen to a few thousand light years out, and catastrophic stellar death, the kind that actually ends a star, is rare on human timescales, even for stars that are due. Take Betelgeuse, the red shoulder of Orion. It's a red supergiant, one of the most watched stars in the sky because it's genuinely near the end of its life, in astronomical terms. Near the end, for a star like this, could mean tomorrow. It could also mean another 100,000 years. Astronomers don't have a countdown clock. They have a range. In 2019 and 2020, Betelgeuse dimmed dramatically, and speculation exploded that it was about to go supernova. It wasn't. Later research traced the dimming to a dust cloud the star had thrown off, cooling part of its surface. Then in 2025, astronomers confirmed something even stranger. Betelgeuse has a close companion star, nicknamed Siwarha, and its famous slow mood swings. The brightening and dimming cycles people had been watching for signs of collapse are largely explained by that companion, not an imminent explosion. Betelgeuse sits somewhere between 400 and 650 light-years away, depending on which measurement you trust. So even in the best case, if it detonated the moment those 2019 headlines were written, we wouldn't see it until centuries from now. The honest answer is unglamorous. Probably not in our lifetimes, but nobody can rule it out. That's not a cop-out. That's just what an unpredictable, centuries-long light delay actually means. This is the strange trade-off at the center of the whole idea. The stars that are close enough to check on quickly are usually too small and stable to die dramatically anytime soon. The stars big enough to die spectacularly are usually so far away that even if they went out decades ago, we're still waiting on the mail. Distance protects you from certainty. You get the light. You don't get real-time status updates. And it only gets more extreme past individual stars. Point a telescope at the Andromeda galaxy, the nearest big galaxy to our own, visible to the naked eye on a clear, dark night as a faint smudge. It's 2.5 million light-years away. The light arriving from Andromeda tonight left before modern humans existed as a species, before Homo sapiens. You are looking at pre-human light, arriving at a screen or an eyeball that didn't exist yet when the journey started. Go deeper into space, and some of the light reaching Earth's most powerful telescopes left its source billions of years ago, closer to the birth of the universe than to now. Every time you look at a deep sky photo, you're not looking at a place. You're looking at a moment that, for all we know, is long since over. There's a phrase astronomers use, half as science and half as poetry. Looking up is looking back. It's not a metaphor. It's a literal description of how vision works once distance gets large enough. Your eyes never show you the present. Not really. Even the light bouncing off your own hand took a tiny fraction of a second to reach your eyes. You just can't perceive a delay that small. Stretch the distance to a star and the delay stretches with it until it's not imperceptible anymore. It's centuries. It's millennia. It's older than civilization. This is actually the whole reason telescopes double as time machines, and astronomers say that plainly, not as a slogan. Every telescope pointed at deep space is, functionally, a device for looking backward in time. The bigger and more powerful the telescope, the further back it can see. Not further out in some neutral sense, but further into the past, because seeing further always means older light. The most distant galaxies ever photographed show light that left its source more than 13 billion years ago, closer to the birth of the universe than to right now. Those galaxies, as they were when that light departed, may look nothing like they do today. They may not exist in that form at all anymore. We're seeing baby pictures of a universe that has since grown up, changed shape, and moved on, and we have no way to fast forward and check. It also means there's a limit to how far back, or how far out, anyone can ever see. And it's not a limit of technology. It's a limit built into the universe itself. Light from far enough away simply hasn't had time to reach us yet, even after 13.8 billion years, because the universe itself has been expanding the entire time the light was traveling. There's a boundary, called the observable universe, past which no light has arrived, and by definition, never information from beyond it. Not because nothing is there, because there hasn't been enough time since the universe began for anything from further away to catch up to us. So it's not just individual stars keeping secrets behind a wall of travel time. The whole universe does it at every scale, all the way down to the sunlight on your hand. Next time you're outside at night, look up again. You're not looking at the sky as it is. You're looking at a stack of old letters, all arriving at once, some fresher, some ancient, none of them time-stamped.